All right, a good warm up here for us. So with those two functions, I want you to find the domain of both of them, identify any horizontal or any vertical asymptotes with them. Again, it might be beneficial for you to have out your supplemental note sheet with you when you're doing this stuff, because one, we're going to keep adding to it, and two, we're going to use it, then, use it at the same time. Let's deal with the left one first and then the right one second. So, what is my domain of A? What do you got, Mike? I love it. Which means, what is my VA, my vertical asymptote? 0. X equals 0. Yep. Now, Loki, you just said 0, right?
Yeah.
Okay. That is not my vertical asymptote because my vertical asymptote is a line, so it has to be x equals 0. You cannot just put the number there. Okay. Horizontal asymptote. This is from yesterday now. What are my horizontal asymptotes for this one? None? Yep, because top is bigger, bottom is smaller, so there's none horizontal asymptotes here. Yep, none, or like you said, NA, or but you can't put 0 there because 0 is an actual number. Okay, so you got to go with the word none, or not applicable, or there isn't one, something like that. Okay, good on that one. Love it. Now, let's get to the fun one. Domain. No restrictions? No restrictions? No restrictions?
X doesn't equal 6. No, I mean, X doesn't equal
Okay, so
6.
let's tap the brakes here now. Let's go off to the side here. So we would normally say x squared plus 6 equals 0, right? What do you got? 2 or 3? X squared plus 6? Well, instead of doing it the factor way, because it's not factorable, let's do it the square root method. So then we would have x squared equals negative 6, and if I square root both sides, then I get plus or minus, and I get the square root of negative 6, which is I square root of 6, right? And that's imaginary. We're dealing with real stuff, so we can't do it. So this is just all real numbers, which means that there is no or none vertical asymptote. Okay? Now, if we think about it, there are 3 types of numbers in this world. There's positive numbers, there's negative numbers, and there's 0, right? If I take a positive number and I put it into that denominator, I'd have to square it first. So what's it going to be? A positive number squared is positive plus 6. Still positive, right? Okay, so that's going to be a positive number. Positive numbers are. If I put a negative number into that denominator, negative number squared is positive plus 6, positive, not 0. If I put 0 into that denominator, I get 0 plus 6, which is 6, and it's positive. Okay? So it's never going to be 0. So that's that. Okay? Okay? Now, my horizontal asymptote. Aha. What do you got, Phoenix? Y equals 2, because we got the same. We got a degree of 2 on the top, degree of 2 on the bottom. They're the same. So then I look at my V coefficients. That was supposed to be green. I don't know why every once in a while it's not. My lead coefficients are 2 and 1, so then this would be y equals 2. Good stuff. Love it. Okay? On these 3, find me all of the asymptotes, just asymptotes, on all 3 of those. Okay? I was nice and I made the denominator the same on all of them. Okay, so my first question is, do any of them have a vertical asymptote?
No.
No, none of them have a vertical asymptote. Okay, all right. First one, does it have a horizontal asymptote? Yes. If so, what is it? Y equals 0 is my only asymptote for this one. No verticals. Okay. Second one, does it have a horizontal asymptote?
No.
Yeah.
Yeah.
Horizontal. Yes? That's a number. Y equals 2/3 is my horizontal asymptote. Does the last one have any asymptotes? Nope, because we got a big over a small. So on those three functions, those are the only two asymptotes that we could find. Okay? All right. Let's do this. So we're going to add 3 steps to our supplemental note sheet right now. Okay? So the step number, so again, still save space for step 0. Okay? Step 1 you should have on there as find the domain of any and all vertical asymptotes. Step 2 from yesterday should have been find the horizontal asymptotes and how to find all that stuff, right? Okay? So step 3 now, step 3 is you are going to find the y-intercept. The y-intercept is the easiest of the easy ones to find because you simply plug in 0 for x. Okay? So you're plugging in 0 in for x, or you're finding f of 0. Which is when you find f of 0, you plug in 0 for x. Okay? The y-intercept will have the form in your final answer, or if I ever ask for it, it will have the form of 0, comma, some number. My question to you is, how many y-intercepts can our functions have? One. We can only have one. Okay? There can only be one y-intercept. I'm going to add in that there can be none y-intercepts, because if we have a vertical asymptote at x equals 0, which is possible, then there is no y-intercept. Okay? Well, I thought it was at your chair yesterday. Okay? So that is step number 3. So first you're going to find the domain, then you're going to find any vertical asymptotes. Second thing, you're going to find any horizontal asymptotes. Third thing now, you're going to find the y-intercept. Okay? Step number 4 is we are going to then find the x-intercept. Okay? The x-intercept, or intercepts, are a little more complicated because here now, fractional logic tells me that if I have a fraction a over b, that fraction is only equal to 0 if what? Make you think a little bit here. Nope. Nope. If the denominator is 0, then I'm dividing by 0, and that can't happen. Because even though you look like Chuck Norris, you ain't Chuck Norris. The top, right? The top, so if the top is 0, then the fraction's 0, right? Okay? So to find the x-intercept, we are going to set the numerator equal to 0 and solve. Now, how many x-intercepts can we have? It doesn't matter, right? We can have as many as we want, right? Okay? It'll actually be the number of x-intercepts is going to be the degree of the top. Because remember, degree is how many zeros we get for each function, right? So whatever the degree is in the numerator, that's how many x-intercepts you're going to have. Okay? These, the x-intercepts, all of them will take up the form some number, comma, 0. Okay? Again, those would be, so 2, comma 0 would be an x-intercept. 2 is not an x-intercept. With me? 2 is a number. 2, comma 0 is a point. Okay? Both intercepts are points on the graph. Okay? With me on that? Okay? So that's step number 4. So we're 4 steps into our 8 steps. So we're halfway there right now. Okay? Alright? Now, I'm going to have you skip some space. And there actually is some significant space to skip. So I would say on your supplemental note sheet, you should skip at least 5 or 6 lines. Okay? And then you go down to the very, or you could just go right to the bottom of your page. And that's where we're going to find our last step, step number 7. And step number 7 is going to say, now you're going to plug in some other x values using a t-chart and find other points that your function goes through. Okay? And this, now it's goofy because I said there were 8 steps, but step 7 is the last one because step 0 is actually our first one. Okay? All right? Now, I'm also going to tell you that I like to make, and this is just me, you don't have to follow along with me, but I make a t-chart for each zone. And you'll see what I mean by that when we actually do this here in a couple of seconds. Okay? All right? So I like to make a t-chart for each zone because then it doesn't have to be one big old t-chart and I have it right where I want it to be. Okay? All right, so you all have graph paper now. Let's go right to the graph paper and we'll just do this example now on the graph paper. Have out your supplemental note sheet yet for you. Okay? So up at by each piece or by each individual graph, there should be a spot for you to write down what the function is. So you probably want to write down that function. 2x over x plus 1 is our function. Okay? Now, that supplemental note sheet that we have, that's our blueprint. That's our roadmap. You guys probably don't even know what a roadmap is anymore. That's our triptych. Anybody remember triptychs? Triptych, so in the olden days, okay, now this is back when there was a 1 and a 9 before the year, okay, right? So back in the olden days, we didn't have cell phones, okay? We didn't have like Apple Maps that showed you all of the locations along your route and planned your route for you. So you had to go to this thing called AAA beforehand, if you remember, and you could, so you're saying, like, I want to go to Disney. Okay? So AAA would then plan your route, and it would give you this booklet. And in that booklet was like maps. And so it had your route all highlighted for you, and then it had like, at this exit, there's this gas station and this restaurant and this stuff. And, you know, and then so you plan, like, then you followed along in your book as while you were driving down the road. And so like, you want, your ideal stop would be at this hotel in this city, you know, kind of deal. Yeah, it's old school.
So the olden day for a map were basically looked like little scribbles.
No, it was a map. I mean, it was like you have on your phone, but it didn't flow. Like you had to follow along with it. Yeah. All right. So on our triptych, step number 1 says we have to do what first?
Find domain.
Find the domain. How am I going to find the domain?
X minus 1. I mean, actually, it was minus 1.
X plus, I'm going to set the denominator equal to 0. And then I'm going to solve that. And that gives me x equals -1. Okay? So what do I get out of step 1 based off of that? I get the domain is all real numbers, but x cannot be -1. And my vertical asymptote is x equals -1. Now, when we go to our graph, our asymptotes are always dashed lines. Okay? So I find where x equals -1, and I put a dashed line that is vertical, so that's up and down, all the way across my graph. Now again, if you do the like slashes so that you can see it better, that's fine. You do you. Okay? But I know now, vertical asymptote, I cannot cross this graph or that line. Okay? I cannot draw my function through that line. Okay? Step number 2 says what? Find my horizontal asymptote. So what is my horizontal asymptote in this case? Y equals 2. Do we all agree with y equals 2? Degree on the top is 1. The degree on the bottom is 1. They're the same. So I look at my lead coefficients. Y equals 2 is my graph. So I'm going to put a dashed line up to all the way across my graph. Now we'll find out later that horizontal asymptotes are funky, and you can cross a horizontal asymptote, but you cannot cross a vertical asymptote. Okay? Step number 3 then says what? Find the y-intercept. Okay? How am I going to go about finding the y-intercept? I'm going to plug in 0 for x. So that's finding f of 0. So that's going to be 2 times 0 over 0 plus 1. 2 times 0 is 0. 0 plus 1 is 1. 0 divided by 1 is 0. So my y-intercept is 0, 0, the point 0, 0. And then I can go right to my graph, and I can put a dot at the origin. Step number 4 said, now I need to find my x-intercept. So I set my numerator equal to 0. And I solve that, and I get x equals 0. So my x-intercept is also the origin. Okay? That's the one spot where it is for both. Yes, sir. Always. But there might be more x-intercepts. Okay? But yes, if the y-intercept is the origin, at least one of your x-intercepts is going to be the origin. Yeah. Mm-hmm. Okay, so we're through step 4 now, yes? Okay, so now we go on to step number 7. And here's what I was talking about with step number 7. We have 2 zones. So this over here is zone number 1, and this over here is zone number 2. I asked you what defines where a zone is. Vertical asymptotes. Break up your graph into the different zones. Okay? So over on this side, I'm going to make a T-chart. Now I only really need one. Later on, you're only going to need one. Okay? But for right now, we should get 2 or 3 points that are over there. I always like to go just next to the vertical asymptote, so we would plug in -2. If I plug -2 into my function, 2 times -2 is -4 on the top. -2 plus 1 is -1 on the bottom. What is -4 divided by -1? +4. So I would go through the point -2, comma 4, and I would put a dot there. Then I usually like to go one more out, go to -3. 2 times -3 is -6. -3 plus 1 is -2. -6 divided by -2 is +3. So that puts me right there. Then I always like to go out to the end of my graph. 2 times -10 is -20. -10 plus 1 is -9. -20 divided by -9 is a little bit more than 2. Okay? Because 2 would be 18, so it's actually 2.2, which would put me right there. Okay? Then I go over to this side. Now, luckily for us, we already have a point on this side. We have the origin. That was our 2 intercepts. So I can go right to the point 1. 2 times 1 is 2. 1 plus 1 is 2. 2 divided by 2 is 1. So I go through the point 1, comma 1. Then I can go all the way out to the right side of my graph, and I can go with 10. 2 times 10 is 20. 10 plus 1 is 11, and that is just a little bit less than 2. So I'm right there. Okay. Now that I've plotted my points, now I can draw in my function. Now the nice part too is, now that we have our graph, I believe this one said find end and asymptote, yep, then state the asymptote and end behaviors. I'm going to state it, but I'm going to state it in a different spot. Instead of writing it all out, I'm going to show you where you can find it on your graph. Okay? So over here, this would be as x goes to -infinity, my function is approaching 2 from above. As x approaches -infinity is the left side of my graph. It's approaching +2 from above, from on top. Easier to see on the graph than trying to think about it in logic. Over here, this would be as x approaches +infinity, my function is approaching 2 from below, because now my graph is underneath my horizontal asymptote, so it's approaching 2. That's my end behavior. My asymptotal behavior, up here it would be as x approaches -1 from the left, because I'm on the left side up there, my function is going to positive infinity. Down here, as x is approaching -1 from the right, my function is going to negative infinity. So you can see that better when you have the graph. Visual. Questions, comments, concerns, clarifications on any and all of that? Let's try one more. I think there's one more. Yes, there is one more. Graph it, find me asymptotes and behavior. Go for it. So for my domain, I get all real numbers, but x cannot be plus or minus 2, which means I have two vertical asymptotes, one at positive 2, one at negative 2. Whoa. Still didn't work. Come on. Why are you? Alright, okay. Sorry about that. Then, what's my horizontal asymptote? Y equals -2, because we got same over same. So then we've got plug in 0. So if I plug in f of 0, I'm going to have -2 times 0 squared all over 0 squared minus 4. That's going to be 0 over -4, which is going to be 0. So my y-intercept is going to be 0, 0. And my x-intercept is at least going to be 0, 0 also. Okay. So then I would say -2x squared equals 0, x squared equals 0, x equals 0. So we're good there. Alright, so now we got some t-charts to make. So let's start up here. Let's go -3. The nice thing is, because all of these are squared, they should be the same. 3 squared is 9 times -2 is -18. 3 squared is 9 minus 4 is +5. So then these are both going to be -18 over 5. So that's going to be -3 and some change. Let's go out to -10. So then that would be negative 200 over 96 over a positive 10. That's going to be negative 200 over 96, which is a little bit more than negative 2. Then we've got the middle section. So we could go with 1, which is also going to be negative 1. So we have negative 2 over negative 3, which is positive 2/3. So my function,
You said positive 2/3?
Yep.
It still looks negative.
is it a negative divided by a negative?
Oh, wait, no, I'm sorry.
It does look like negative 2/3 because it is negative 2, but then it also is over negative 3. So that makes it the positive this then. My arrowhead. Yeah. So then now we can do all of our wonderful, let's do asymptotal behavior first. So we're going to say as x approaches negative 2 from the left, my function, so I'm approaching the left blue line, is going to negative infinity. As x is approaching negative 2 from the right, my function is approaching positive infinity, because now on this side here it's going up. As x is approaching positive 2 from the left, function's going up. And as x is approaching positive 2 from the right, my function is going down to negative infinity. Arrowhead over here. Then I got my end behavior. As x is approaching positive infinity, my function is approaching negative 2 from below. And as x is approaching negative infinity, my function is approaching negative 2 from below. Questions, comments, concerns, clarifications? Seeing none, you have now the ability to do all of this week's blue homework. Yep, so you can do now all of it on the blue worksheet, formative assessment tomorrow, and then that blue worksheet is.
You did earlier for